Did you know that the same industrial processes that created jobs and economic growth also left behind a legacy of soil contaminated with probable carcinogens? Did you know that some of that soil is right here in our own backyard? Less than 30 miles from New York City, industrial processes contaminated the soil and groundwater for decades with dozens of contaminants that threaten the water supply of this densely populated area. But it also really distresses the land value. And so what happens is these sites typically abandon. So a site that once created possibly thousands of jobs sits empty, and that has a huge impact on a community. There are over 450,000 brownfield sites, contaminated sites in the US, and they contain over 100 billion tons of toxic soil. And yet less than 0.1% of that soil is being treated due to cost. The soil has to either be excavated, taken someplace and buried, or treated with energy-intensive chemical or thermal processes. There has to be a better way. Allied Microbiota uses microbes to clean contaminants from soil. And our microbes have shown groundbreaking results against compounds like those polychlorinated biphenyls, PCBs, polyaromatic hydrocarbons, PAHs, dioxins, and chlorinated compounds. With the support from the National Science Foundation and New York's Clean Energy Business Incubator program, we've moved that technology out of the university to our lab here at the Advanced Energy Research Center, where we've shown that our technology works. We've shown in the lab that we can take PCB levels down below 50 part per million, and that's a key regulatory threshold that allows the soil to be safely landfilled. But we're not stopping there. We're working hard to get the PCB levels down below 1 ppm. At that point, the soil can be safely reused, solving the problem, not burying it. ThermO is a natural microbe, and this microbe is really fantastic. They can not only survive in these toxins, but they kind of eat them for lunch, using their metabolic processes to break down these toxic compounds into harmless substances. We're often told that the solution is to dig up the soil, transport it hundreds of miles, and bury it. That doesn't solve the problem. It just relocates it and buries it. When we say that we can solve the problem, we're told that it'll be too expensive and too slow. We disagree. Our microbes can degrade environmental contaminants faster and cheaper than existing remediation technologies. Communities shouldn't have to choose between jobs and a clean environment. I want our generation and the next to feel safe eating food grown in their garden, eating the fish that they catch, and drinking water from their tap.
What a great tagline, to use microbes to turn brownfields into greenfields. We are joined now by the CEO of Allied Microbiota, Laura Lynn Kortz. Hi, Laura Lynn.
Hi, Julie. It's great to be here.
I think where I'd like to start with questions for you, because this is such a large problem as highlighted in the film, is how you will take this amazing ThermO microbe and get it into market. Who will your customers be? And how are you going to break into this soil remediation industry already in place?
That's a really great question, Julie. At Allied Microbiota, we're blessed and cursed by the fact that our technology has such a broad range of applications. From soil contaminants like polychlorobiphenyls, PCBs, and polyaromatic hydrocarbons, to water contaminants like 1,4-dioxane and dioxins, to industrial off-gases like formaldehyde. In fact, we issued our first commercial invoice for air contaminants during our time at IndieBio, and received multiple samples of water contaminants from interested customers. However, our hard work at customer discovery during the IndieBio program showed us the huge size of the soil market and the regulatory drive to clean it up. Government regulations are forcing landowners to clean contaminated soil before the property can be sold or developed. For this reason, we're going to focus initially on excavated soil contaminated with one of the toughest contaminants, PCBs. Tough that is, except for our product, ThermO, which eats it for lunch. And after that, we're going to move to decontaminating the soil on site. Initially, we're going to work with partners, environmental engineering firms, to de-risk our technology before working directly with the customer, the landowners.
What additional insights can you give us into the soil market that you mentioned you discovered through your IndieBio customer discovery process? And how will you compete cost-wise with the existing technologies?
Yeah, the soil market is really massive. Over $8 billion a year is spent to clean up contaminated soil. And that's just in the US. And that's just the excavated soil. The go-to solution right now is typically excavating and landfilling the soil, which can cost, depending on the level of contaminants in the soil, anywhere from $50 to over $200 per ton. And that's just the tipping fees, not to mention the cost of excavating the soil and transporting it. Successful on-site treatments include chemical and thermal processes, but they can cost over $300 to $500 per ton. Working with a commercial partner, we successfully treated tons of soil and showed that our technology works and that we could access 1 billion of that $8 billion soil market right now. And based on this study, we were able to show that our ThermO process could treat contaminated soil at the cost of $60 per ton. And that makes it competitive today for PCB-laden soil that's destined for TSCA-regulated Class C landfills, which cost about $200 per ton. However, as we scale up and move our production process out of the lab to a commercial facility, we'll be able to take those costs down to about $20 per ton. And by treating the soil on site, we'll be competitive with Class D landfills, which cost about $50 per ton. And at that point, it's an easy decision for our customers to make, to clean up the contaminants rather than bury them.
Cost competitive and more sustainable. It's a winning combination. Now, your technology is rooted in bioremediation, a field that's been around for decades, really. So I'd like to hear how Allied Microbiota is different than previous companies working in this space. And since you mentioned that ThermO is a natural microbe, if you could incorporate how you will protect your intellectual property, that would be great.
Yeah, that's a great question. You're right, Julie. Bioremediation has been around for a long time, but we've never seen a microbe like ThermO. It's really an amazing microbe that's supercharged by heat and oxygen, which empower it to break down the toughest contaminants in weeks to months. Traditional remediation practices typically take years to decades. Compounding that problem, most microbes can only tackle a narrow range of contaminants, and oftentimes can only break them down partway. That means that multiple steps are required to decontaminate the soil. ThermO, by contrast, can tackle a broad range of contaminants from PCBs to PAHs to 1,4-dioxane, and it breaks them down quickly into harmless cellular building blocks. And you're right, ThermO, it's a natural microbe, and we plan on protecting P by developing these IP-protected remediation modules, essentially black boxes, which contain our microbe and an IP-protected nutrient cocktail. In addition, we're developing microbe delivery vehicles to increase our product's efficacy and to strengthen our IP position. So we already have one patent that we're licensing from Columbia University, and during our time at IndieBio, we filed 2 additional provisional patents assigned to Allied Microbiota.
All right. Well, I think my final question here is, what are you fundraising and how will you use this to take ThermO to all of the contaminated soils?
Yeah, we're looking at $1.5 million to supplement our funding from the National Science Foundation and New York State's Clean Energy Research and Development Authority. And we want to use those funds to develop and deploy a ThermO remediation unit that can decontaminate excavated soil. This module can be deployed at the site of contamination or as a unit of operation at a commercial soil handling facility. In addition, we want to develop and deploy a ThermO remediation process that can decontaminate the soil at the site of contamination without needing to excavate the soil. And we also want to improve our production process and increase the specific activity of our product. So these steps will allow us to decrease our costs, increase our margin, and accelerate our ability to remove contaminants.
Well, thank you very much, Laura Lynn, for answering my questions today. And thank you for taking the time.
Thank you, Julie.